Now we're going to be dealing with dividing square roots. Once again, we do not want, most of the time, we do not want a square root in our denominator. What we have here in this problem, 5 over the square root of 7, is we in fact have a square root in our denominator. We need to go through a process to remove this square root from the denominator in such a manner that we do not change the value of this fraction. Well, the method that you go through to remove a square root from a denominator is called rationalizing the denominator. So once again here, if we take a look, our strategy here will be to remove this radical sign. Well, we could do that by simply multiplying it by some other type of radical. If that radical, when multiplied, gives us an answer that's a square. Well, instead of trying to figure all that out, oftentimes the simplest thing to do is just to take whatever this term is down here and multiply both the top and bottom by that same term. So that's what we're going to do here. We're going to take our radical 7, multiply our top by radical 7, and then multiply our bottom by radical 7. Once again, radical 7 over radical 7 is 1, so we're just simply multiplying our original fraction by 1, which is not changing the value at all. At this point, since we're multiplying fractions together, we multiply our numerators. 5 times radical 7 is simply 5 radical 7. And then in our denominator, radical 7 times radical 7 is 7. The square root of 7 times the square root of 7 is 7. 5 radical 7 over 7 is our simplified version of 5 over radical 7, and we got this answer by getting rid of the radical sign in our denominator, and we did that by multiplying both our top and bottom by radical 7. Let's take a look at another example here. This time we have 1 over 2 plus radical 8. In our denominator now we have two monomials. We have two terms. 2 here and then a radical 8 over here. So what we have here is a little bit more complicated. We just can't go now and multiply the top and bottom by radical 8 because that's still going to leave us 2 times radical 8 plus 8. We're still going to have a radical sign in our denominator. And that's because we have more than one term here. The process that we went over on the previous screen of taking and multiplying the top and bottom by the same radical number only works as if you have one term in the denominator. Over here we have two terms in the denominator, so we're going to have to make use of some other type of strategy. Well, the strategy that is oftentimes very helpful is to multiply both the top and bottom by a polynomial such that it not only gets rid of this radical sign, but it gets rid of the middle term. Because remember, when we factored things before, you had x plus y times x minus y. By using the distributive property, you got a middle term. You not only had an x squared and a y squared term, but you also had an xy term. We have to make use of what are called conjugates. Conjugate is basically what polynomial do we need to multiply by this one so that we get the difference of two squares. If you remember the difference of two squares, and I'll just write it here quickly and then I'll go ahead and erase it. If we had a minus b times a plus b, and we went ahead and used our distributive property to multiply or distribute this out, a times a would be a squared, a times b would be a plus ab, then a negative b times a would be a minus ab, and then your minus b times a positive b would be a minus b squared. This plus ab and this minus ab, they cancel each other out, giving you 0. And then what that leaves you with is a squared plus a minus b squared, which is just the same thing as a squared minus b squared. So as you notice here, in order to end up with this a squared minus b squared, we had to take our first polynomial here that had two monomials in it, two terms, a minus b, and we had to multiply that by a plus b. Well, let's say instead we had started off with a plus b. What would we have to have multiplied it by then? A minus b. Well, using that same imagery, we can actually come over here and use that difference of two squares to find out what we need to multiply this by. 2 corresponds to A, plus radical 8 corresponds to B. So what do we need to multiply by? A minus B. Well, what's the A? The A is 2. What's the B? The B is radical 8, but this time it's going to be a minus radical 8. So what we're going to do is we're going to multiply both the top and bottom by 2 minus radical 8. And at this point, I'm going to go ahead and get rid of that, get it out of our work area. We're going to go ahead now and multiply. We're going to multiply two fractions together by multiplying our numerators. 1 times each of these things is just going to be itself. 1 times 2 is 2. 1 times a minus negative 8, or minus the square root of 8, is minus the square root of 8. So that's our top. Now our bottom, we have to use our distributive. 2 times 2 is going to be 4. But remember, 2 times this minus square root of 8 and this positive 2 times the square root of 8 are going to cancel each other out. So then the last thing to multiply together is the positive square root of 8 and the minus square root of 8. And what that's going to give us is a minus 8. Now let's go ahead and simplify even further. 2 minus radical 8 is this, we can leave that alone, or if you want to factor out a 2, you can go ahead. 2 times 1 is 2, and 2 times radical 2 is radical 8. Remember, think of this. Radical 8 is the same thing as 4. Radical 4 times radical 2. The square root of 4 is simply 2. So we can factor that 2 out, and we are then left with radical 2. And then in the bottom, we have minus 4. We could even take it one step further. This 2 and this 4 can both divide by 2. So if we divide the top by 2, that's going to leave us with 1 times 1 minus radical 2, which is just the same thing as 1 times 1 minus radical 2. And then if we divide the bottom by 2, minus 4 divided by 2 is just simply minus 2. So 1 over 2 plus radical 8 in simplified form is 1 minus radical 2 over minus 2. And the reason why, once again, this is in simplified form is our radical is now out of our denominator. The only thing we have in our denominator over here is an integer, a minus 2. Let's go ahead and do the same type of thing to this next problem, same type of methodology. 3 over 4 minus radical 6. Once again, we're going to use our conjugate strategy, and that is by multiplying the top and bottom by a polynomial phrase such that we are left with the difference of 2 squares in the bottom. Well, what's that going to be? Well, what we have here is a minus b, so what we have to have is a plus b, don't we? Well, a is 4 plus b, the b being the square root of 6. That's going to be in our top, and we're also going to multiply by that same in the bottom. See, once again, here's our a minus our b, our 4 minus radical 6, and here's a plus b, a 4 plus radical 6. We can now go ahead and multiply it out. 3 times 4 is 12. 3 times radical 6 is 3 radical 6. Then in the bottom, 4 times 4 is 16. Our 4 times plus radical 6 and our 4 times minus radical 6 cancel each other out. And then minus radical 6 times positive radical 6 is a minus 6. On the top here, if you want to factor out a 3, go ahead. We can go 3 times 4 plus radical 6. So remember, 3 times 4, that's the 12. 3 times radical 6 is this 3 radical 6. And then in the bottom we have 16 minus 6, which is 10. So 3 over 4 minus radical 6 rationalized is 3 times 4 plus radical 6 over 10. And remember, once again, rationalizing is the process, rationalizing a denominator is the process whereby you remove any square roots from the denominator itself. Over here, lastly on the review, conjugate. Many times to remove a square root from a denominator, you got to multiply that denominator by its conjugate. The conjugate of the polynomial is the polynomial that when multiplied by what you have in your denominator will give you the difference of two squares. And by going through that process, it will then remove that radical sign or square root sign from your denominator. That wraps up session 85.